Okay, here we are. It's the January 2015 IAL S1 paper, and I'm stuck with question 1. I'm going to whip through this as quickly as I possibly can. Let's see how long that takes. So here we go. Write down the value of D. So we've got a discrete random variable here, and so it can take the values 1, 2, 3, 4, 5, and these are the different probabilities. And they've given us here the f of x, which if you remember is like the cumulative distribution. It reminds us up here, if you can't remember that. So we know that if we're it's a cumulative, which means that we're adding up as we go along. And so by the time we get to this final value here, it should be 1. And the first question asks us anyway what D is. Well, D is 1, because we're adding them up as we're going along. Right, so now to find out the values of A, B, C. So that's going to be easy, isn't it? Because 0.1 add what makes 0.26? That's 0.16 here. So A is 0.16. So that should be D equals 1 there. And then here B is going to be this, add that. So that's 0.54. B is 0.54. And C is going to be what add on to 0.54 makes this. So that's 0.22. C equals 0.22. Cool. And that's all of that done. 4 marks. Right. Write down the value of the probability of x being greater than 4. So it doesn't equal 4. So basically it's just this one here. Sorry. Probability of x being greater than 4 is just, it can only be 5 then. That is the only value it can take on. And the probability of that happening is here at 0.24. So that's the answer to that question as well. Yeah, so that's 0.24. That's another mark. Right, 2 independent observations, x1, x2, taken from here. And what's the probability that they're both odd? Right, okay, what is the probability that one of them's odd? Is going to be, there could be 1, the value of 1, value of 3, and the value of 5. Well, so if it's 1, the probability is 0.1, or, so that's a plus, 0.28, or, so that's another plus, 0.24. Let's add those together. So that's 0.62 is the probability that one of them is going to be odd. And so we need to, the probability that both of them are odd, we're just going to need to do the probability of odd and then another odd, so the probability of odd, and that's multiplied by the probability of the other one's odd, is 0.62 times 0.62. So let's see what that comes out at. 0.62 squared is 0.3844. 0.3844. That's the answer to that. To do. Okay, given that both of them are odd, find the probability the sum of them is 3. Okay, so the probability, I need to have a bit more paper here. So if they are both odd, what's the probability that the sum is 6? So we could have, if the first one is 1, then we need the next one to be 5. So we need it to be 1 and then 5. So the probability of us having a 1 and then a 5 is one of the things that could happen. Or we could have a 3 the first time and a 3 the second time. They add up to 6. Or we could have a 5 first and then a 1. Okay, so what's the probability of that happening? Probability of us having a 1 first and then a 5 is going to be 0.1, because that's a probability of a 1, sorry, up here. Probability of a 1 is 0.1, and a 5 is 0.24. So 1 and a 5 is 0.1 times 0.24, and then we replace the or with an and with a plus, and then we've got probability of 3 is 0.28 times 0.28, and then another plus 0.24 times 0.1. Okay, let's work out what all of those are. So we've got 0.1 times 0.24 is 0.024 plus 0.28 squared is 0.0784, 0.0784 plus, and then this is going to be the same as the first one, 0.024. So the probabilities of those added up together are times 0.024 plus 0.024 is 0.1264. 0.1264. Right, okay, so it says given that x1 and x2 are both odd, which we've worked out here. So whenever we have a given, we know that goes on the bottom of the fraction, so that's 0.3844. Given that this, what's the probability of that? So let's work that out. 0.1264 divided by the answer is no. 0.1264 divided by 0.3844 is 0.3288. 0.3288. That's the answer to part E. And that's the end of that question. So that's 3 marks. So that's all question 1. That's pretty cool, pretty quick. Right, question 2. Apologies, I've written on this already, so sorry about that. Okay, so let's have a look. We've got stem and leave, or we've got back-to-back stem and leave. And it's about a sports teacher recording the number of press-ups done by students in 2 minutes. And here's year 7, here's year 11. Okay, and we've got back-to-back stem and leave. Okay, so having a look at this. Find the median number of press-ups for each class. So that's pretty easy. How many are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9. Did they not tell us? No. 1, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, they did. 16, 23, 26. So that's 31 altogether. And over here we've got 14, 21, 22, 32. Right, so we're going to have to find halfway for our medians. Okay, you've got a choice here. You can either remember that you have to do n plus 1 divided by 2 for discrete data, or else you can just count in half and go find halfway. But anyway, so 32 divided by 2, so it's the 16th value, so it's 10 along here. We'll know there's 6 there, 10 here. So do you know what? I'm sorry, I already circled what the median value here is for year 7. So year 7, the median is 29. And for year 11, we've got 32, so it's 33 divided by 1. So we know it's going to lie between the 16th and the 17th value. So it's 5, 10, 14, 15, 16. So it's between here, so it's going to be 54. So equals 54. Okay. So the year 11s managed to do more press-ups than the year 7s, which we would expect, wouldn't we, really? Okay, 40 press-ups. Find the median for each class. Right, so the median, we've just done, sorry. For year 11 class, the lower quartile is 30, upper quartile is 59. And now we're going to find those for the year 7 class. Okay, so that's pretty easy because we've got 32 altogether. We did 31 and add 1 is 2, so it's 32 divided by 4 is the 8th value. And so the 8th value is 6, 7, 8, so it's that one there, 22. So quartile 1 for year 7 is 22, and quartile 3 is going to be 8, 16, the 24th value, so that's 10, 16, 23, 24, 25, 26, 27, sorry, I said the 24th value, right, 16, 23, 24 is there, so that's 42. Right, and that's for year 7, okay? And now we're going to use the medians and quartiles to describe the skewness for each of them. So let's have a look what's happening. It's telling us to look at the quartiles and medians, so let's have a look. Quartile, if I do year 7 first, quartile 3 take away quartile 2, which is a median, is 42 minus 29, so that gives me 30, 12, 13, and quartile 2 minus quartile 1 is 29 minus 22, that's 7. Okay, so that's a bit biased. That's year 7, and year 11 is quartile 3 take away quartile 2 is quartile 3 for the year 11s. They've told us here is 59. 59 minus 54 is 5, and quartile 2 minus quartile 1 is 54 minus 38. That equals 54. I've made such a mess of this. That's 16. Okay. Do you know what? I'm just going to draw here how that looks. So for my year 7s, if I had to draw a box plot, I'd have, we've got it 13 over here and 7 there. All right. And my year 11s, it would look like I've got 5 there and 16 there. Gosh, okay. So for this one, it's going like this, and for this one, it's going like that. Okay, so this one, the year 7s have got a positive skew, and the year 11s have got a negative skew. Okay, that's interesting. And now finally for part D, give 2 reasons why the normal distribution cannot be used. Well, okay, for a start, it's discrete data, so we can't use the normal distribution because it's discrete data. So that's one reason why not. And the second thing is that normal distribution assumes symmetry, obviously, and neither of these are symmetrical, so let's put not symmetrical data. Okay. Right, that's the end of question 2. Okay, here's question 3, and we're looking at the price of bottles of milk in pence and loaves of bread. So this is a milk and this is a bread. Okay, and they've given us some information here as well, so we need to make sure we don't ignore that because we're probably going to need that later on. So I'm just going to highlight, they're going to be the S of BB and the S of MM, and they want us to find the sum of BM, the sum of BM. So basically we're just going to times these two together and add them all up. Okay. So here we go. 29 times 75 plus 29 times 83 plus 35 times 91 plus 39 times 121 plus 41 times 120 plus 43 times 126 plus 44 times 119 plus 46 times 126. 33856 is the sum of all of those. So that's 33856. Okay. Now we're going to find the S of BM, and that's probably why we needed that. So let's go to our formula sheet, and S of BM is here. Sum of BM take away sum of B times sum of... Right, let's go for this then. Let me write it down. Sum of BM minus the sum of B times the sum of M divided by N. Okay, it's all there in your formula sheet. So we've got that part equals 33856 minus, well, the sum of M, going to have to add all of those up at the top. It's a bit tedious, isn't it? 29 plus 29 plus 35 plus 39 plus 41 plus 43 plus 44 plus 46. So they come to 306. I'm going to put here equals 306, just so that I've worked it out. And then sum of bread, 75 add 83 plus 91 plus 121 plus 120 plus 126 plus 119 plus 126. 861 times 861. Let me write that here as well. 861. And we're dividing all of that by n, and that's 8. Alright, so that equals 33856. 33856 minus 306 times 861 divided by 8 equals 922.75. It's amazing how they give us all these marks for doing basic GCSE maths. Right, so that's that one. Product moment correlation, coefficient between B and M. So back to our formula sheet. Product moment correlation coefficient here is S of xy divided by square root S of xx, S of yy. So let's write that down. So we want the S of BM divided by the square root S of BB times the S of M equals, right, let's just plug in some values then. S of BM, we just worked out here, is 922.75 divided by the square root of S of BB, which they've told us here, 3083.875 times 305.5. Don't forget, guys, I've always told you not to do these S of XX questions actually on the question sheet, and now I'm just doing exactly that, so that's really bad. But anyway, let's see what that equals. 922.75 divided by square root of 3083.875 times 305.5 equals 0.95. Nice tight correlation there, 0.95. I'm going to just put 07 there, 07, because it kind of goes on. And now interpret it. Right, well that's nice and easy, isn't it? Because it's close to 1, close to 1 plus 1. Therefore, quite a strong positive correlation. Basically, price of milk increases, so does price of bread. Okay, a 9th year is added on to the end, and in this year the price of a bottle of milk is 46p. I'm going to write it here. Squeeze it on here. Well, pop those like that to be ignored. So 46p for milk, that's the same as it was then. And bread is 175p. My word, what happened that year? So milk stayed the same, but bread's gone shooting up by almost 50p. So that's a massive jump in the price of bread. Now, without further calculation, state whether the value of the product moment correlation coefficient will increase, decrease, or stay the same when all 9 years are used, and give a reason. Okay, right, so I'm going to have to go to a piece of paper here now because I'm fast running out of space. Well, obviously, what's going to happen is that the line of best fit, if you like, the correlation between the two. Now I'm adding one where the bread is, at the moment, bread and milk are like this. But now if I'm going to add the price of bread and milk, and I'm going to have a piece of data that like there, like way away from it, then this value, the 0.95, is going to change. It's going to become weaker. So 0.95 will decrease, won't it? It will decrease. It will get nearer to 0. Closer to 0. So it will decrease and get closer to 0. What's it saying? State whether the value will increase, decrease, stay the same, and give a reason. Because the milk remained at 46p, but bread increased by nearly 50p, which was massive. So of course that's going to have an enormous effect. Okay, I think that will answer that question enough. Do you know, just to be super duper safe, and because the examiner probably won't understand my sketch here, I'm going to write the new value. The new value is further away from the line of best fit. Okay, cool. Right, that's the answer to question 3. Moving on to number 4. Okay, question 4, sadly, the only sheet I've got with a question on, I've already written all over, so that's a bit annoying. But anyway, I'll talk you through it. Really easy question this was. So, events A and B are on the Venn diagram, and they've filled everything out except for X and Y. So find the expression in terms of X for the probability of A. Well, the probability of A is obviously going to be this plus this, isn't it? So probability of A is just X plus 0.1. Okay. And the probability of B, given that it's in A, probability of B, given that it's an A, is that we're looking for, let me find a different colour pen. So it's given that it's an A, we always write down the probability of the given A at the bottom, that's a fraction. So given that it's an A, probability of A is x plus 0.1 from here. And the probability it's B is this value here. Alright, that's the probability it's B given that it's in A. Well, there's only one thing it can be, that's 0.1. So it's 0.1 divided by x plus 0.1. Okay? No simplification needed, that's it. That's just the end of that one. Right, and then for part B, find an expression in terms of x and y for A union B. Well, guys, that's just everything that's here, isn't it? Running out of different colour pens now. So all of this here, all of that is A union B. So therefore it's x plus 0.1 plus y. And yeah, I've written down here that it equals 0.68, and you can see that it equals 0.68 because we've got here 0.32, so 1 minus 0.32 is 0.68. So all of these three added together must equal that, 0.68. Okay. So now they're saying to find, given that the probability of A is 2 times the probability of B, find the value of x and y. Okay, so let's write this down. Probability of A, so probability of A we've already got here. So x plus 0.1 equals 2 times the probability of B. Well, the probability of B is y plus 0.1. Yeah? So let's get rid of the brackets. X plus 0.1 equals 2y plus 0.1. And now I'm going to put all the x's and the y's on the same side. So I'm going to go x minus 2y equals 0.1. So that's 0.2. 2 lots of 0.1 and 0.2. So x minus 2y is 0.1. Okay, so I'm going to end up with 2 equations here. They're simultaneous equations because the values of x and y are shared for both of them. I've got this one over here as well. So let me write this down. X plus 0.1 plus y equals 0.68. Let me get the x and the y's on the same side again, the same as I did there. X plus y equals, take that away, 0.58. Here are my 2 simultaneous equations. Right, so let's get taking them away. I'm going to start my biggest one on the top because I just like having positive values. 0.58. Sorry, it's getting a bit messy now. So that one's there. Then I'm going to bring this one down. X minus 2y equals 0.1. I'm going to take them away because I want to get rid of these x's. Now I've got y minus 2y is y plus 2y, so that's 3 y's equal 0.58, take away 0.1, 0.48. So therefore y equals 0.16 because that's divided by 3. Okay, if y equals 0.16, we know what x is going to equal now because x plus y is 0.58. So x plus 0.16 equals 0.58. So therefore x must equal 0.42. Okay, now if I put those values back in, so I've got y equals 0.16, x is 0.42. Okay, let's just add everything, make sure it all adds up to 1, 0.42, 0.52, 0.84, 0. Yeah, so it all adds up to 1, so therefore we've cracked that question. Nice and easy.